Have you ever wondered why sticking a cold pizza in a warm oven actually works? Well, it all comes out to the idea of heat. And heat is energy that exists because of differences in temperature. Even in the room that you're sitting in right now, you are surrounded by different objects that actually have different temperatures. If you've ever sat down on a cold seat before or put your hand on your desk, and have felt either cold or maybe hot, that's because of heat exchanges. And the way that heat works is heat moves from warm objects to cold objects until the two objects have the same temperature. And so, my favorite example of this, as I just alluded to, was the whole pizza idea. And the way it works is that you have an oven that has heated up the air inside the oven to some really high temperature, 350, 400, 450 degrees, and then you take this cold pizza and you stick it in there. Now you have two objects with very different temperatures. You have a warm oven, or at least the warm air inside the oven, and a cold pizza. Well, heat then travels from the warm oven into the cold pizza. And what happens is, as the cold pizza absorbs the heat, its temperature goes up, 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 and up. At some point, you take the pizza out. If you left it in there, it would eventually be the same temperature as the air in the oven, and you'd have a very burnt pizza. But how does this happen? Well, there are actually three main types of heat transfer that we're going to talk about in this investigation. The first type is what is called conduction. If you've ever touched a hot spoon before, or even putting your hand on your desk and it feeling cold, that is conduction. Basically, what you are doing is that you have directly contacted something that has a different temperature than you, and heat then travels between these two objects, your hand and the object you touched, until the two have the same temperature. If you've ever gone to a bonfire before and had the experience of heating a s'more on a wire hanger, and you didn't insulate the wire hanger at all, well, what actually happens is heat will travel from the fire into that wire hanger, and then and that's done via direct contact, and then the heat travels through the wire hanger and into your hand via direct contact. And that wire hanger is what's called an intermediate object known as a conductor. So that's conduction. The second type of heat transfer occurs whenever you're boiling a pot of water. If you've ever boiled a pot of water before, you know that bubbles start rising up. Well, inside those bubbles are very warm air and very warm water. And that is water that's been heated down near the base of the pot that was heated up via a flame, and the bottom of the pot gets really hot, then the water gets really hot, and then that heat rises. And that's what convection is. It's the transfer of heat via bubbles in a fluid. And the main one we're going to talk about in this investigation, however, is radiation. Radiation is the heat that you feel when you're standing out in the sun. So you have this big burning ball of hydrogen out 93 million miles away from here, and it's heating you up. Now, in order for it to heat you up, that heat has to make that 93 million mile journey through empty space. And the way it does it is via magnetic waves of energy that we call radiation. If you've ever felt heat coming off of a bonfire, even though you weren't touching the bonfire and you weren't directly above it, so it wasn't conduction or convection, that heat that you were feeling was radiation. And what's interesting is that there's some pretty cool properties of radiation that I'll actually talk about in a future video. Okay.